Hello everyone, welcome back to day 2 of Arduino Week. Today is going to be really devoted to the Internet of Things, and you'll find we've got a really packed agenda, both of community members sharing their wonderful projects with all things IoT, and we've also got a few expert speakers to share their knowledge around the subject. So just to run you through our first session that will be taking place, we have Chris Rogers, a professor of mechanical engineering at Tufts University, and he's going to be talking about how teaching the Internet of Things brings the world into the classroom. So he'll be sharing his amazing insights. We've then got Carl, our resident Arduino expert, who's going to show you hints and tips for home automation using the Arduino IoT Cloud. And then finally, we've got Dia from ARM, who's going to be walking everybody through a virtual hardware solution that they have, which is very, very impressive. So without further ado, I'll introduce you to Chris and bring him into the talk.
Good morning. Can you hear me?
Morning, Chris. Yes. Chris is based in the US, so it's a very bright and early start for him. So we're very pleased to have him join the talk. How are you doing, Chris?
I'm doing well. As you can see, it's a gorgeous day out there.
Wonderful. Right, so Chris is going to share his expertise around teaching the Internet of Things in the classroom. I will try interview him, but he's kind of away and above and beyond me with everything that can be done. But Chris, if we could just get into a start, really around, a bit of background to the Internet of Things, why it's important for students to learn IoT in the classroom.
Sure. So it's pretty exciting to see, and a little scary to see how the world is going completely online, that people are always connected, whether it's your house, your car, your kids, you name it. And along with that comes a certain responsibility, I think, from the education community to make sure that people understand the concerns around privacy and around identity theft, and all of these play a huge role in how you set up your IoT. So that's why I think it becomes important to bring IoT into the classroom so that students get some sort of idea of what they're dealing with.
Yeah, we kind of see it in that they will need to solve their day-to-day challenges and problems using IoT. So it brings an interesting perspective on it. Because we did kind of phrase today's session of it being bringing the world into the classroom. Can you share any insight around that and how you see it being different to your kind of everyday classroom lessons?
Yeah, so one of the beauties of open APIs is that you can access anything. So you can find out where the space station is at the moment. You can find out where your car is at the moment. You can find out how many teenagers smoke. You can find all sorts of different pieces of information just right there in the classroom, so that suddenly your questions become, instead of become something that's very confined into the classroom, you can have robots. I teach a lot of robotics, so most of mine are robots. You can have robots that are reacting to one of my students built a thing that rotated the globe to show you exactly, and had a laser pointer to show you exactly where the space station was viewing. These are things that 20 years ago we never would have even thought would be close to possible.
Thanks, Chris. So given that typically, I'm just thinking of how, when I was at school, the teacher would say, right, you and your partner, take the tools in front of you and do X. Given that the scope of this and the scale has just been blown out of the water and that it can be anywhere around the globe, do you have any tips on where your typical teacher should start with this?
Yeah, so there are a bunch of different ways of beginning. The easiest, of course, is to just do a Google search and look up some of the information and pull the information the old-fashioned way with paper and pencil from online. However, once you start thinking about introducing sensors from different places around the world and having classrooms actually take data that they share around the world, you start to get much more exciting ideas that come out, and of course, many more technological hurdles that have to be overcome. We just were working with a school that just had their students in Mongolia share a virtual space together in real time, and suddenly they're talking about designing things together with different cultural backgrounds and different goals and visions. It's pretty exciting what can happen.
Wow. And I'm just thinking of the different cultural goals and the different insights. So given that there's no right or wrong answer, I can just imagine that sets a different type of challenge for a teacher, nearly in terms of how do they grade things. Have you got any hints on how to approach that?
So yeah, so in my mind, there's two things we need to think about as teachers, whether you're teaching kindergarten or college. You have to think about this idea of do I can teach the student my thinking, or I can teach the student how to think. And these are two different concepts, right? And so if you think about it, a lot of times we are teaching the students our thinking when we have them memorize Newton's laws or take our interpretation of the book they're reading. But we spend a lot less time listening to the kids' ideas and having the kids tell us what they think the author is meaning in the book, or what they think the sun is doing as it's rotating around the earth in their mind. So how do you balance these two in the classroom? And one of the ways we balance them is through projects and project-based learning. And one of the measurements I use to look at the success of how much I'm getting the students to think on their own is what I call solution diversity, or the diversity of solutions across the classroom to any problem I give. So if I ask the kids to add 2 and 2, I'm going to get a solution diversity of 0, right? There's only one answer, and everybody will be trying to replicate my thinking of the addition and tell me the answer I'm expecting. If I ask them how many different ways can I pull things together to make 4, suddenly there are many more options, right? And so I start to get a much higher solution diversity. With that comes the problem that you were just saying. It's okay, it's easy to grade whether or not they got 4. It's a lot harder to grade their different paths to get to 4, and is one path better than another? And so grading becomes a little bit more challenging. And there are a couple of different things that I've used in the past. I think the first thing is to look back at the reason that we do grading. I'm not sure that it's always great to have the person who's actually trying to mentor a person also be the judge of that same person, right? It's like asking a parent if their kids are great. The answer is kind of obvious. Yeah, they're great. And asking a parent to say, well, which kid is better is very difficult, right? And parents rarely will answer that question. But that's exactly what you're asking the teacher to do. And so maybe it's better to rethink, what is the goal of the grading? The grading is to try and give some impression of the knowledge the student has gained throughout the class, or the knowledge the student has the material in the class. And maybe that's better done if we look at how the art world does it, or the music world, right? They don't give a grade to the different artists or musicians. The artists and musicians build a portfolio to show off what they do and how they interpret music and so on. And why can't we do the same thing in the classroom, having students build portfolios of what they're doing? These portfolios are becoming more and more important, especially for my students when they look for jobs, because now almost every industry will want to see, what have they done? What have they engineered? I don't want to know how well they memorized how to solve Bernoulli's equation. I'd much rather see, have they been able to actually apply Bernoulli's equation to real world environments? And so a lot of it goes to trying to get the kids to build portfolios. Once you have portfolios, then there's a long answer to your question. You can grade that portfolio in a number of different ways, right? You can have peer grading, where the kids actually try and assess each other's portfolio. A lot of implicit bias, a lot of different biases come in through that, but no different than when the teacher is actually grading, or a panel of experts, or bringing people in from the outside. So all of these are possible, and the best solution I found is to try and mix all of them, so that there's no one set of biases that's biasing the overall grade.
Yeah. Okay, sounds really good, and it does show, that there is ways around this. I especially like the artist comparison, in that we often refer to STEM, or in our case STEAM, and I think that obviously adding the art in there is certainly applicable. I was also, just as you were talking about that, Chris, and you mentioned the real world applications, it made me think that, a lot of this, the students actually can't see what's going on. It's out there. You mentioned students talking to other people in other classrooms over in Mongolia. So I'm just intrigued, is there any kind of difficulties that students have by the fact that a lot of it is virtual? Or is that my kind of old-fashioned way of thinking, and are they just beyond that and it all comes naturally to them anyway?
Well, I think a lot of that, again, it's a spectrum, right? If you're talking about actually the ability to reach out and talk to somebody like we're doing right now and be in different places of the world, that's pretty natural to them. If you're talking about reading requesting the temperature in Botswana and getting back a number, that's a little bit probably less meaningful to them. But then again, if you did the same thing locally and you asked your temperature sensor for a number, that temperature sensor is reporting back something that you probably don't understand either. It's some sort of weird box that's in the room and giving you a number too. So in both cases, you got to figure out, well, how do I know that number is right? In the case where the box is in the room, it's a little bit easier. If the box says it's freezing and you're in a t-shirt, probably the box isn't working. If the box says about the temperature you expect, it's probably doing a good job. You're not in Botswana at the moment, so it's a little bit harder for you to now test that number coming from Botswana. And so getting the student to think about, well, how do I verify that number is correct, is part of the scientific thinking that we're trying to teach them.
Okay, thanks for that. And any kind of, it's such a broad range of devices and applications. I think I saw the latest piece of information was saying there'd be 15 billion devices connected to the Internet of Things by the end of 2022. So we must be getting very close to that number already. Any tips that you would give to an educator who's thinking of bringing IoT into the classroom?
Sure. Yeah. So there's a bunch of things. So first, obviously, you got to start simple. And there are a number of websites out that you can get a piece of information with just a single query. So you need to find some way. It depends on what age group you're working with, of course, but you have to find some way of getting the student to actually query for a piece of information and get that information back. That means they're going to have to learn something about REST API and something about JSON, since those are sort of the standard ways of the information being moved. Neither of those are very complicated, at least on the onset. They have complexities once you get into them. So I typically will start my students out being over in the US with them trying to find a Chuck Norris joke. And there are a number of places where it's a single line. It's very easy. There's no security. And then eventually we get to the point of doing all the security and all the issues around security. And then how do you actually get Google Slides to show up data that's coming off of the sensor in your backyard, plus the sensor in Botswana at the same time, in a graph that actually is an embedded Google Sheets spreadsheet as well, is something that my students have done, which is just amazing that they can do that.
Okay, thanks, Chris. I'm just looking through. We've got a number of questions coming in from the community whilst we've been talking. We've got one that just says, I'm just curious, those who teach with Arduino, are they primarily IT teachers or other disciplines, such as physics or biology? What's your kind of findings with these things?
Unfortunately, I have no strong evidence one way or the other. I'm sure somewhere we could find a REST API that could give us an estimate. I have seen Arduino in particular and other microprocessors in general being used everywhere from the arts and stage settings to taking data in the physics class to a robotics class, etc. Most of the cases I've seen have been STEAM related. So it tends to, from my experience, it tends to be biased more towards the STEAM world. But one of the things that's neat is to see all the different ways people use the tools.
Yeah, and and I could add from our own perspective from Arduinos, we do see, obviously, primarily the majority would be in IT teachers, but yes, it's across the other disciplines. We get a lot of interactive arts using Arduino, When you tend to go to code clubs, it's not necessarily the IT teacher who's running those at the schools. It can be from any discipline. You know, I've seen many a physics teacher who's also involved with Arduino, for example. Let me just look. We've got one about certification. Can we get a certificate for joining this program and learning Arduino? We don't currently have a certification IoT based. There is the certification program for learning Arduino fundamentals, and you can find that course online, and it's available for anybody to take who's kind of started on their Arduino journey.
Again, I would suggest the best way to demonstrate your abilities is to develop your own portfolio, build your own web page, use Wix, Google, you name it. There are tons of different tools out there that you can start building a website, and make sure to take pictures document the journey you take as you're inventing some crazy thing.
Okay, just trying to see if we've got any other questions for Chris whilst we've got him. No, I think, Chris, we've covered off the questions that have come through. So just to say thank you very much for your time. Certainly appreciate it. It's a very early start for you over in the US. So thanks for sharing your kind of expert insights with the Arduino community. I'm sure they'll have taken a lot from that. Thank you very much.
Sure. Thanks for having me.
Great stuff. Thanks. So now we've got our resident in-house expert, Carl, who's going to introduce the kind of using Arduino around the home to help with home automation projects with his unique hints and tips. Over to Carl.
Hi, everyone. I'm Carl. I work with the Arduino documentation since a couple of years back. I have been working with the Arduino IoT Cloud basically since it was in the beta stage, and today I'm going to show a little bit of tips and tricks that I've learned over the years. So first of all, for those who doesn't know the Arduino IoT Cloud, it's a service that allows you to basically configure, program, and deploy your devices all from a web application. And in some simple terms, it's the same as an Arduino IDE, but it's on the web, and it also allows you to control and monitor your devices from afar. So I'm just going to share my screen real quick here and see if I can get my thing there. So there we go. So the the Arduino IoT Cloud consists of, well, let's say two main components, and it's the things and the dashboards. And today I'm going to show you a little bit about a project I just made. It's called the RGB lights. It's a very simple product, but I'll show you like a little bit about the basics of the Arduino IoT Cloud. Here I have my variable, which is a cloud called light variable. I have a device, which is called RGB lights. And I have my network, which I need to connect, when I need to enter for the device to connect to. And this is simply your configuration for your projects. And when you create these kind of things, it automatically generates a sketch. And this sketch is more or less just a composure of all of your different configurations. And it includes different files as well, such as your thing properties. This is when you're thinking about these kind of sketches, they're not exactly the same as your typical Arduino sketch, but what they do is they maintain the connection between the device and the Arduino IoT Cloud. And all of this is done more or less automatically. So if you can see in this sketch here, we have nothing in the code or nothing in the loop. We just have Arduino Cloud updates. And we have a little bit of code that will help us turn on an RGB matrix. And this is a little bit how it works. So you start off with a setup, and then you have a sketch. And today I'm going to show you a couple of tips that will help your experience here in this scenario. So after you have created a project and you have uploaded a sketch, I've already uploaded the sketch and I have my device working here. I can actually upload the things over the air. And this means that if my device is connected to the network and it is powered up, I do not have to physically connect it to my computer to upload it. And this feature is, of course, really, really nice. It means that if you have devices all over your home or your office or your school, you can upload to them without having them physically connected to your computer, which is a real game changer, in my opinion. Enough with that. My second tip of the day is that you can actually connect several devices with each other by enabling variable synchronization. And variable synchronization works so that if I create a variable called, let's say, call it test switch, and I make it into a Boolean, I can select the sync with other things and select any of the Booleans that I want to synchronize with. And when I did that, you can see that a lot of these variables automatically will filled in, and that's because they were already in sync. So that means that when I click on the synchronize variables, I now have something like 10 or 15 variables that are in sync. This means that whenever test switch is true, all of the other ones will be true. And this is really useful if you want to, for example, turn on or off all of the lights in your house at the same time, or if you want to set a parameter for example, a motor, the speed of a motor. And that's about it. That's probably one of my favorite features because it requires no extra setup in terms of code. You basically treat it as any other code, and that's about it. And to move on, my next favorite feature or a tip that I would like to share isn't really a tip in itself, but it's just to highlight the fact that we have a large amount of widgets. And widgets are basically the building components of the dashboards, as we call them. Dashboards are used to control and monitor your devices. And inside of these dashboards, or inside of these widgets, you can link them to your variables. We have about, I think it's 17 widgets, and all of them have different purposes. So for example, the switch button is very easy. You can just turn on or off something. Or you can select a percentage, which will monitor the percentage of something. For example, moisture in a plant or the humidity of your home. You can also use a little bit more sophisticated ones as the color widget that will allow you to set the specific RGB value for example, a RGB LED matrix. And these widgets are really, really sophisticated in the way that they are in real time. So whenever I change a parameter here, it will automatically change on the device. More than that, if you have a lot of sensor data, so I'm going to show you my personal dashboard that I have of my home. It contains a lot of plants and the temperature widgets and humidity. Now, this is not live. I pulled the plug a couple of days ago, but you can see that I have data that indicates that my living room plants are doing okay and the temperature is fine and so on. I can download the historical data by clicking on the button and selecting the variables. So for example, in this case, I can select all of the widgets that are in this dashboards and get the data. And this will be sent, a link will be sent to you on your email, and you can download it directly. Some other cool things with dashboards is that you can, for example, auto-generate a whole dashboard based on your thing. I went to the thing there. Here I have a widget that's called the battery tester, or a dashboard called the battery tester. let's say that I want to add the data from another thing. So let's say the living room, which has a bunch of variables. If I click on all of these and click on Create Widget, you can see that they auto-generate. And this means that I can add from other ones as well. For example, from the sunroom, has a lot of different sensor values, and it automatically generates all of them. This is a real time saver, and it's a tool that allows you to build dashboards that can control multiple devices really fast. Sorry about that. And one of my for one of my final tips of the day, I would like to introduce you to the remote app. So the Arduino remote app is basically a mobile version of your dashboards. And these ones, let's see if you can go to here. If you want to control your home from your phone, but you don't want to access the cloud website, you can actually design a mobile layout, which looks like this. So this is the desktop layout, and this is the mobile layout. So when I open my phone and my phone app, I can actually control all of these, monitor my phone, or monitor my device from afar. And that's a really nice feature because it allows you to control anything for not sitting by your computer. So you can control lights with your phone, and then it makes it more than just a fun product. It can actually be really useful. And for my final tip of the day, I would really recommend you to look into the Alexa integration. So we have made an integration with how we can add Alexa voice control to any of your Arduino projects. In the documentation website, you can see really detailed instructions on how to set it up, such as setting up your Alexa skill and so on. And this allows you to interface the Alexa app together with your Arduino Cloud and your device. So you can use commands such as Alexa, turn on the lights, and it will turn on. And you'll find a lot of information on both the documentation site and on the cloud.arduino site about how to achieve this. And that's about it. I don't have anything more to share. So I think we can move on to some questions that you might have regarding the cloud, and I can see what we have. So there's a question here that comes in. Which boards can connect to the Arduino IoT Cloud? So there are quite a lot of boards actually that are capable of making a connection to the cloud. Sorry. And there is from the Nano family, we have the Nano RP2040 Connect, and we have the Nano 33 IoT. So both of those have a Wi-Fi module and can connect to the cloud in just a couple of minutes. Then we have also the Maker Wi-Fi 1010. We have the Maker 1000, and we have the Portenta H7, and we also have the Maker GSM board. And the GSM board is a bit different. It requires a SIM card to connect, but it's really useful because you can basically stick it anywhere there is a connection, which means it doesn't have to rely on a Wi-Fi connection. And that makes it a little bit more superior. There's also the LoRa boards as well. And the LoRa boards have a module that allows you to connect to different LoRa gateways through the Things stack. So you can stick your board with a small battery. As it is optimized for low power usage, and where there's no internet, and it can send data to where there is a gateway, basically. Another question that come in here. Can you tell us a bit more about the map widget with the GPS shield? So yes, the map widget, something that I overglossed a little bit there, is so you can enter coordinates either manually or interactively. So if you have a GPS shield, you can continuously read the data from the GPS module and update the cloud. So in the Maker GSM board is a perfect example of how you can do it. So the Maker GSM uses cellular connectivity, so it can be placed on, for example, a car that would continuously record the GPS data and update the cloud with it. And the map widget would allow you to see exactly where this board is. And that's more or less the best practice for it. There's another question here, and it says, do we have any options for power over Ethernet on nano boards? Not quite. Yeah. So at the moment, there's no board that has no nano board that has an Ethernet connector. So that's not possible. You can of course use other shields and make the connection, but there's nothing that is directly compatible. So yeah, so I don't see any more questions. So I'll just say thank you all for watching, and I'll bring Keith back in here to join the conversation. Hi, Keith.
Hi, Carl. Thanks for that. Very insightful. I'm sure people have picked up some great tips for how to improve their home automation and using the IoT cloud. So greatly appreciated.
Yeah, and thank you for having me, and have a great rest of the Arduino week.
Will do. Thanks. Okay, everybody, we're just going to take a minute or so's break whilst we set up for the next session, where Massimo is going to be joining us to speak to Dia from ARM about virtual hardware. So if you'll just give us a minute to swap mics, we'll be back on very, very shortly. Thanks, and see you soon.
And we're back. Thank you very much. I'm Massimo Banzi. You might remember me from yesterday. I'm here to introduce a special guest, Dia Subra, who is the director of at ARM, and he's going to be talking to us about this new technology they developed, which is called virtual hardware. But I'm not going to go into too much detail. I will introduce you to Dia. Hi, Dia. How are you?
Hello, everybody. I am super excited to be here. You know, to me, it's a privilege to be part of Arduino Week. Thank you.
But thank you for coming. So I was doing like a quick anticipation about your presentation, which is about this new technology that you guys have developed, which is about virtual hardware. So maybe why don't you take 10 seconds to tell us a little bit about yourself, where you are located, what's your role in ARM, and then let's jump to talk about the project that you've worked on.
Absolutely. So my name is Dia Subra. I've been in ARM around 9 years now, focused on embedded and IoT. And my last 3 years been totally focused on the smart home. So I am the person in ARM responsible for the smart home segment, working in what we call the IoT line of business. And I'm based in France, because ARM has a design center in the south of France, Sophia Antipolis, near Nice.
That's super nice. And, not bad, compared to other locations in the world. Sophia Antipolis, near the seaside, it's pretty good. Okay, so apart from the jokes, let's talk about this virtual hardware. Can you tell us a little bit about this technology? I know you have like a little, maybe you can just tell us about the technology. Then I'll have a couple of more questions after you sort of explain.
Yes, absolutely. So I'm going to use my hands to describe our virtual hardware.
Please do that.
Good to speak like that. Yes. So we are here today to talk about the ARM virtual hardware. And before we jump into what is it, I wanted to just mention in a few seconds. So why are we doing this, right? Why did we develop the ARM virtual hardware, right? And so if people would ask the question, so what are ARM and Arduino trying to do in the big picture, right? And the answer is, in reality, is we're trying to unlock the power of technology to spark people's potential. So it may seem like, it's like, what do you mean spark people's potential? But actually, people have so much ideas, so many opportunities. So somebody has to remove barriers, the technology barriers, so that people can use the technology for opportunities that they see around them, right? Mm-hmm. So if you take every single person, they have ideas, they see problems, they know what the solution is, but they may think that the technology is too complex, so it's not for me to offer a solution. So we're trying to show everybody you have what it takes to actually go after that opportunity. And this ARM virtual hardware is another element in making technology accessible to everybody, right? So what is this ARM virtual hardware technology? Okay, in straightforward terms, it is a functionally accurate model of an ARM-based chip, and the model runs in the cloud, right? So keep that in mind as we go through the rest of the discussion. It's a functionally accurate model, which means this virtual hardware, it simulates the behavior of the hardware as seen by the software, right? So if you put yourself as the software running on a piece of hardware, you expect to see a certain behavior, because that's how you got this contract between the two. So this virtual hardware simulates exactly what that software expects to see. One way maybe to visualize it is to think about the virtual machines in the cloud today, right? So if you compare virtual machine to virtual hardware as a specific virtual machine designed for ARM-based IoT, available in the cloud, right? And so where you end up with is, with this virtual hardware, all IoT developers can now, as we say, can leverage, right? They can have the power, they can leverage the flexibility, scalability, and the power of the cloud, so they can increase their productivity, because now they have access to these modern cloud-based development techniques that we call, let's say, DevOps, MLOps, and CI/CD, the continuous integration, right? So by opening the door to all these cloud techniques, IoT developers now have this extra power in their hands. And so to give you 3 use cases to demonstrate where this could be used, the simplest one, of course, is the ability to start writing software before the hardware shows up. I mean, people don't think about it, but I know in the personal case, I've had many super ideas, and I'm like, oh, can I go in and try it? And the immediate reply is, oh, I have to order the board. I have to wait for the board to show up. Okay, which it's going to show up. And so think now about the case where you do not have to wait for the board to be shipped to you. You can actually launch the virtual hardware, start writing your software, and then the board shows up and you just transition to hardware. It's very straightforward, right?
Mm-hmm. Yep.
That's one. The second one is, in this universe of advanced development in the cloud, there is this thing these days called the continuous integration and development, which means you do not spend a year writing something and then you deploy it, and then you go back for 1 year to write something else and deploy it. Now it's continuous. So you actually develop the thing, you ship it, it's working. Meanwhile, you changed it, you ship it again. By ship it, meaning you deploy it, right? So this continuous integration and development, it's really hard to scale. And by scale, we mean, what if you want to deploy 100 boards, right? So usually people would have to physically put those boards in their lab, wire them all up, and be able to work with them. But now you can say, well, if I have the board as functionally equivalent in the cloud, I can actually have 1,000 boards. Actually, there's no limit to how many boards you can have. And if you imagine a test case, so if you had one board and you have 1,000 test cases, let's say, you'd have to run them serially, one after the other. You can say, well, if I'm in the cloud and I can have 1,000 boards, I can run 1,000 test cases in parallel, right? And all of a sudden you have all sorts of possibilities that open up, because then you can say, oh, I can even force corner cases, because basically I control everything. It's just software in the cloud. So I can create corner cases and I can test things that would have been really hard to replicate with a physical board. Now, the last one, which will be really interesting now, as we enter the age of machine learning, right?
Yeah.
Everybody now wants to put machine learning at the edge, as we call it, which means in the device, at home, in the factory, right? And so now you actually have to have people sit down and create a model and see if it works on that piece of hardware. And so now imagine if that data scientist who's working in the cloud to create the model can also test it on a virtual hardware, and hence closing the loop. So you create your model, you test it on the hardware, you tweak it, change the model, test it again, and when you're finally happy with it, you can just send it to the actual device. And again, this comes back to scale, right? Because I'm in the cloud, I can scale without limits. So if we apply it to ML, you may go through 100 iterations. So you can see time-wise, it's serial. But now picture the case where I can have 100 variations of the model and test them all at the same time, right? And you can say, well, why stop at 100? I can actually do 1,000, right? And then you can say, well, anyway, I'm going to try pick hardware. So I can actually test my ML model on different types of hardware and pick the one that fits, instead of actually buying the different boards and saying, is this better or is that better? And so in the end, you have this ML running on this virtual hardware. And even though it's a functional model, you can still get notions of the instruction count. So if you're trying to make your ML network better by running it in the virtual hardware, you can actually see if it's getting better or if it's getting worse. And of course, you can see how much memory it's taking. So you can see if your work is actually giving you a better result or not. And so the way to see this going in the future, right? Because we're just starting right now. And so you have to imagine, where are we going to be over the next year, the year after, and so on. And the best way to see that is when you look at the cloud-based development. 5 years ago, where was that development and where is it today, right?
Oh, yeah.
Today, you can see anybody can just get online in the cloud, develop an app, and then launch it, let's say, via containers to thousands of nodes, and make changes and deploy it again. And everybody sees that as natural. I mean, nobody thinks twice about, yeah, I just made a modification and I just deployed to my 100 nodes that are distributed globally. The people now take it for granted, right? And it's not only special applications, it's all developers, all applications. So we believe by doing this on virtual hardware, we are opening the door so that in the future, this would be a natural sequence in doing developments for IoT, right? All these IoT developers are going to have this cloud-based development where they can just write the application, test it at scale, and when they're happy with it, they can just deploy it, which is what the cloud people do today. And so we're back to, why are we doing this? It's because people have all these wonderful ideas, right? And so somehow you have to let them do it. And you may have seen it in the industry before, that there was an estimate that the IoT development, the IoT deployment is supposed to reach 1 trillion nodes, right? We're not talking about 1 billion. In the previous session, we were talking about 15 billion. Actually, the famous projection was 1 trillion. And actually, what is the barrier to get to 1 trillion? Well, it's very easy. If you let people develop and deploy, we can easily get to 1 trillion. And we think AVH, the ARM virtual hardware, is one of those elements that's going to accelerate by allowing people to do this. So I've talked a lot. Sorry about that.
No, it's okay.
My colleague in ARM, Sandeep Mistry, has created an example because people want to actually see and not just hear, right? So my colleague has created an example. Somewhere we're going to share a link. And
yes, we have a URL, we have a GitHub, and it's showing up on the screen right now. So anyone who wants to try this code, they can go to this URL, and they also get the instruction on how to set it up. Yeah. So I think it's pretty cool. And so, yeah, no, I think I love the idea. There's this idea that you can, in a way, emulate the hardware before you actually have hardware, or this idea of the kind of the multiple deployment in parallel sounds really cool. Actually, yes. I've never thought about it, and now that I think about it, it's just pretty amazing that you can try the same thing in parallel with thousands of instances. That would open up a lot of possibilities that we don't have right now. So I have a couple of nerdy questions. Is there a specific architecture that you are emulating right now with this virtual hardware, like a specific processor that you're emulating, or?
We are simulating all the Cortex-Ms. So from the Cortex-M0 all the way up to the Cortex-M55, and I believe they also released Cortex-A somewhere in there. I have to check on that, but I believe that's also in there. So Cortex-M0, M0 Plus, of course, M3, M4, M7, M33, M55, and they come in as a like a subsystem where you've got the memory, the interconnect, and so it is the functional model of the base of the device, of the chip. And I saw the question about, does that mean people can build virtual hardware of their own spec, right? With the models that you have access to, they're already prepackaged, right? But we are working to have extensions so that people can actually add to it. And I don't know if how far that would go. But as I mentioned, this is just the start of the journey. So I'm pretty sure a year or two from now, you're going to have all sorts of stuff around the ARM virtual hardware.
Yeah, no. So in fact, one of the things I was asking myself is that if it would be possible, for example, for people to write emulation for specific peripherals, for example, and add them to this thing. That would be one of the possible extension for this.
Yes.
Okay, so that would be very cool, because then obviously you can basically simulate what goes on around the processor, and then you put it in this virtual machine and you emulate it. The fact that you cover the whole range of Cortex-M, it means that you can suddenly, simulate the code that would run on several different Arduino boards that are based on ARM processors. So it's actually quite interesting, because at the moment we have a piece of software that we wrote that kind of automatically compiles every library that exists for Arduino to see which one are broken, quote unquote. So the ability to actually run them on a simulated processor would increase, the kind of checks that can be done automatically without special hardware.
Exactly. I mean, imagine if every time you touch the code anywhere, you can just run it to check that nothing got broken on any Cortex-M or any board model. Yeah, that is one part of it. Yeah.
I have a quick last question from the audience. Is there any documentation, paper, or software for such approaches? I have been looking for such an approach in which the user can work with virtual device and test the program and see. So these are, I guess, is everything kind of linked from this GitHub, or is there like a specific place on the ARM website where people can kind of go a little bit deeper into the technology?
Yes. So in the ARM website, of course, on the developer website, there is the ARM virtual hardware page with the full details. And basically what you need is the GitHub, where you have all the code, which includes all the documentation. So what you're seeing here as the link is the specific project that's using the ARM virtual hardware with the Arduino IDE, right? And then in the main GitHub, there's everything with example code, which has also more documentation. Yes.
So there's a couple of more quick questions. Are there any plans to extend the virtual hardware to include off-the-shelf products like communication modules or shields, but running purely in the cloud? So is there a plan to extend the emulation beyond the processor itself and other things, or?
So all of this started last October, and we have lots of people working on it. So you are bound to see updates for this thing. I cannot say today what are the specific updates or when they are going to show up, but I can say that we see this as a fundamental technology for IoT developers. So you can be assured that ARM is investing heavily in this, and we would be doing many more things to it. And the things you mentioned about the peripherals, that was like the #1 request from everybody saying, yeah, we love this thing, but can I add our peripheral to it? And we're like, yes, okay, we'll figure it out. Yeah.
So the very last question is actually a very good suggestion, maybe for the team, because the person was asking if it would be possible to simulate network failure and tower dropouts. So, for an IoT developer, the fact that you could then, in a way, simulate bad quality connection or no connection, it's something that would be very useful to kind of, check the robustness of software firmware. So is there any plan for that as well?
Well, yes, because see, what happens now is when you do this virtually in the cloud, obviously there's no more a radio in that sense. It's all just software in the cloud. And so the way this is done is the actual radio driver is replaced by a virtual driver, which just is a byte stream, right? Because all you're doing is you're simulating a packet that comes from the radio, or actually comes from, like Wi-Fi, Bluetooth, or whatever. So the fact it's just a virtual driver of a sequence of bytes means you can now, that's what I meant by you can simulate the corner cases, because it's under your control and it's software. So you can actually drop packets, add packets, do redundancy, and lose packets. And as far as the software is concerned, from a functionality perspective, it's receiving a packet from a radio, which you've modified in any way that you want. Hence, you can simulate any corner case that you want.
I mean, this is great. It sounds like the first step on something that's going to be really, really important. So, well, first of all, thanks for releasing the code, and so that people can start to play around. And also we're looking forward to see new improvement, new addition to the technology. So for now, thank you, Dia. We thank you for participating and for giving us this intro to the technology. And we'll see you soon. Thank you very much.
Thank you so much for having me, and I wish you a wonderful Arduino week.
Thank you very much. Bye-bye.
Ciao. Bye.
Ciao. Okay, so this is the last session before the break. Basically, after this session, there will be a session with community contributions, so presentations from the community, and there will be a keynote presentation from, I'm very honored to say, my personal friend Benedetta Piantella. Will talk about her work in technology for, in a way, for social impact, in a way. So thank you very much for attending this session, and see you at 5 p.m. CET. So that's about an hour from now for the next session. Thank you very much. See you later.
Hello, welcome to the Arduino Week 2022, and I am sitting in Malmö, Sweden. My name is Laura Balboa, and I am working on hosting today. I'm really happy to be here, and I work with product delivery and releases in Arduino. And today is day number 2 dedicated to IoT, and this is like the next segment that we have after a short break. And we are going to have really, really nice talks, especially right now with a VIP interview with a really special person that has also been a host in previous events for Arduino in Bar Arduino. So I want to welcome Benedetta Piantella, who is a designer that also became an educator and also is a humanitarian technologist. I really like this definition that you have of yourself, Benedetta. How are you?
I'm good. How are you?
I like your clothes. We are like very colorful,
All for you.
Great.
Thank you so much for having me, and happy Arduino week.
Yeah, we are really happy because we are going to have a lot of community projects. We are going to have Q&As. I think this is a great opportunity to expand the activities for from the Arduino Day to a whole week of activities. So what are you going to show us? I mean, I'm really looking forward to know more about the work that you have been doing for like social impact, but specifically your career, but also how you have been using Arduino, of course, in the different projects that you have been doing. So feel free to drive
Yeah.
us through it.
Yeah, I'm happy to share some projects, and I guess this is sort of my my tribute to Arduino and what Arduino has allowed me to do over the years. So yeah, just a little bit about me. My name is Benedetta. I go by Benny. I'm a faculty at NYU Tandon School of Engineering, but I also do lots of community-based research projects. And I run a lab here at NYU called Low Power Lab. So I won't, start from the very beginning, but I'll start from 2004, which is when I survived the tsunami, the Indian Ocean tsunami in 2004. And this was a very pivotal moment, not only because I realized that like makers, hackers, artists, and designers could actually lend their skills to these type of situations, but also because I realized that my education up until that moment had sort of failed in preparing me for these type of events. And so that's something that, like, as an educator, I very much try and fix with my teaching. So although I had some experience with hardware at the time for art purposes, I was making interactive installations mainly. I didn't get to learn about Arduino until I actually got to grad school a year after the tsunami. And so that's when I started to play around with Arduino. And my very first project was really aimed at helping me understand the science behind tsunamis better. I realized that I didn't understand that phenomena. And so I wanted to kind of use this opportunity to see if I could replicate, what at the time was a $400,000 system to detect tsunamis in deep ocean with just a few $100s worth of open source components. And so that actually started this process of questioning. And I wasn't not only allowed and able to learn more about tsunamis, but also start to think about how we can actually bring these concepts to a wider audience. And so it actually ended up being a live music performance where this buoy in Brooklyn Bridge Park actually created music based on tides and based on waves. So this was kind of the very beginning of my Arduino journey. But yeah, Arduino has really helped me to sort of formulate research questions, and then through hardware prototyping, not only answer those questions, but get to much deeper questions. And so my very first like real project in the social impact space was this collaboration with UNICEF. Again, it very much started with a design provocation and a specific research questions. We wanted to see if we could use open source networked hardware to actually sort of take over paper forms, and how sort of paper-based diagnostics was really an issue in rural clinics. And so this was not only my very first experience in the field, but it really allowed me to understand better how systems work and how everybody is part of a larger system. And also really figure out what prototypes actually are good for. And so this taught me the value of prototyping throughout the research process, but primarily as a way to actually ask deeper questions from users and stakeholders. And so this is a lesson learned that I carried throughout the rest of my projects. A few years later, I was lucky to work with biologists, Maasai herders, and lions on a project trying to understand if you could use, again, open source technologies to alleviate the human animal wildlife conflict. And so this was also a super fundamental project because it allowed us to understand human behaviors better, understand animal behaviors better. I was introduced to the concept of environmental stewardship through this project, which is something that like I champion a lot. And also, through answering a lot of questions, it brought us to understanding how lions sleep a lot. And so we thought about, should they be wearing a solar cape while they sleep, while the actual like lionesses do all the work? Or they move so much and they cross country borders during migration that since our solution was actually based on cellular connectivity, we had to have some funny conversations with telecommunications companies about providing the Lions with roaming plans. And so these were just, some fun facts, but because of how open and accessible, the Arduino platform was, we were able to very quickly iterate and get to that point. So the majority of kind of my earlier work in the humanitarian space, as well as in the sort of what some folks will call ICT or ICTD space, information communication technologies, where basically trying to assess whether or not the Internet of Things, which at the time wasn't a thing, it was, the beginning of connected devices, could actually be used to help communities rethink their relationship to infrastructure. And actually redesign infrastructure in such a way that it provided them with much more equitable, timely, reliable access, and allowed them to actually only consume and pay for the resources that they actually needed. And so this example was a shared solar microgrid project where really rural communities could finally pay and afford electricity on demand. And then this was providing communities with access to clean water 24/7 in a very sort of transparent and equitable way. So these are just, briefly some of the, and there's an Arduino inside every single one of these projects. And so what really Arduino allowed us and all of our partners and collaborators, and these are all massive collaborations, as all projects in the social impact space are and need to be, really allowed us to use this platform to formulate questions, answer research questions, and create, at the beginning, sort of one-off experiments that then turned into actual open source platforms with documentation so that students, researcher, designer, artists, hackers could actually build their own versions in their own communities. And then it even led to products, to actual kind of innovation and new hardware projects based on these experiences. So as I mentioned, this is sort of my, thank you to the Arduino team and the platform and the entire community for allowing us and all of our partners to actually explore these really deep-rooted, challenges, and for making all of this possible.
And thanks to you. I mean, it goes back and forth because it's, a collaboration and things go back to the community as well. I mean, you have been doing great work, changing the community situation in different places as well. So just remember that we are going to have now, we can start now with a Q&A for Benedetta. If you have any questions about the projects that she has been presenting, about herself, or anything else that you want to ask. So we have a question right now. How do I get into your line of work, research with a technological focus?
Yeah, so I think, I think it's a great question. And I think that the technology aspect is sort of an addition to, I think that the key element in this question is the research element, right? And I think there's research opportunities all around us. A lot of these projects took place, outside of where I live. But a lot of the projects that I'm actually involved in now are based here in New York in my own community. And so I do work with my community garden, helping them think through certain interactions, as well as whether or not they need solar. So I think that finding spaces in your own community or community-based organizations that are around you, and engaging with them and really kind of getting to know their ethos and what type of opportunity they have can lead to really interesting and impactful collaborations, because you actually have access to those communities, you're invested in them, and you can actually help them, design and implement something. And those can turn into really interesting research projects as well, right? So you can both do the design and the implementation, but you can also formulate interesting questions to answer through that process. So that would be my, my short answer to that.
Good. And also because I guess, I think that research is very important through like the development of Internet of Things through the years. So you have to really, go into the research and development loop every time to be able to improve your project.
Yeah, and these are, outstanding issues that have been, as I mentioned, these are like wicked problems, right? They've been around for a really long time. They exist in all contexts. And a lot of people have tried, so finding those precedents and really learning from previous attempts or previous systems or previous solutions that might have worked or might have not worked or, failed partially. I think it's really important not to kind of repeat the same mistakes in a way. And so I celebrate failure in this space very much because we tend to kind of, I think, make the same assumptions and so design certain solutions with the same thinking. And a lot of those things have failed. And so it's really important to kind of figure out what's been done already in that space so that we can learn from those previous examples.
Of course. We have another question. It says, did you already know how to use Arduino, or did you learn it for a specific project and then it became part of your work more often? I think you sort of like partially answered with your presentation, but if you can develop a bit more.
Also great question. I come from the art space. So I was an artist. I was a visual artist before I got introduced to physical computing through a class at the Massachusetts College of Art called Electronics for Artists. And at the time we were using the basic stamp and kits. And so that was my first introduction to hardware. So I didn't know Arduino until I think 2006 or 2005 is when I started playing with it. And I just learned it through doing. And so all of these projects were just kind of very practice-based. As I was developing different projects, I learned to work with it as a material. And then it became part of my everyday and my bread and butter, I guess.
Great. We have another question, but I wonder if we have time because we have some other community projects, and I could spend hours and hours talking about this. But I don't know if you can maybe respond this very quickly. So
Yes.
It says, are people coming to you with their needs for existing projects, or are you starting your own social impact projects?
Yeah, I love this question. A combination of both. So the UNICEF project that I presented was very much an ask. UNICEF had identified a lot of issues and had speculated on a prototype. Turned out to be that, doing research, you find all kinds of other aspects that they had actually maybe missed. But I also, other projects come from just observation. And as I mentioned, from engaging with local communities and kind of seeing what their challenges are and helping them think through new solutions. So it's a combination of all of those things.
Both. Great. Thank you. Thanks a lot for sharing this and sharing all of this great work that you have been doing. So
thank you for having me.
Thank you, Benedetta. And just greetings from Malmo to New York.
Yes, to you too. And thank you and happy Arduino week.
Thank you. Good. So we are going to move next to the community projects. So I am going to show you or present this to you in 2 blocks. We have 4 community projects. So let's go to the first block with the 2 community projects, and then I will introduce the other 2 straight after. So first of all, I am going to present to you the project from Jesus Hidalgo from Venezuela. So, and it is not that we were talking about IoT and about environments. This project is about rain gauges and how control systems work, how can more control and improvements on control systems for rain gauges can be improved, especially for sprinkling systems. So let's check this out. And the next one that we are going to present as well is from Vatsalya Baduria from India, who is also, I mean, I love that we have young people also presenting community projects. This is awesome. So this project is about smart farming, and we are going to get to know how the hardware that was designed and this Android application can show real-time moisture and temperature data gathered to control, all of the smart farming projects. So this project is using ISP and sensor technology. So let's watch this, and then I'll come back and show you the rest of the projects. Thank you.
Hi everyone, my father is a passionate meteorologist and a retired university professor. He has always said that if you want to find quick and easy weather forecast books in a bookstore, you should look up in the esoteric section. Of course, he's just kidding. What it means is that the weather interpretation needs accurate and constant measure. And even today is not that simple. I've measured the rain since I was a child. First, we did it in the very old-fashioned way. We used a rain gauge, ruler, pencil, and a notebook. Later, we were able to use electronic weather station. All of them have pros and cons. Some of the problems include as bird nests or beehive. For those reasons, I've never stopped dreaming about a rain gauge with little use of solar energy. No mobile parts, neither water collectors. I became a mechanical engineer and a university professor with an entrepreneur company called Endeavor Consult. In recent years, we have installed more than 120 sensors to measure air temperature, pressure and humidity, water tank levels, energy quality, and so on, with low cost and reliable technologies such as Arduino. In 2014, my father, another university fellow, and I studied a commercial satellite TV signal loss during rainy days. This is a well-known undesirable effect for many users, because you lose your favorite movie scene at the most important moment. But for us, it was a wonderful opportunity to relate the satellite strength signal with the rain. As the rain becomes stronger, the satellite signal strength turns weaker. But still extracting that signal from a TV decoder to a computer is not an easy task. So we turned it into two new advances. First, a wireless communication technology called LoRaWAN, that means long-range data transmission for several kilometers at very, very low energy consumption rates. Second, another initiative called Helium Network that took the advantage of blockchain technology to encourage deployment of a public network by anyone, anywhere, and that's it. It opened us a golden door because the LoRa signal strength behaves similar to satellite during rainy days. Any LoRaWAN node device is potentially a portable rain gauge. Easy to connect wherever you go, regardless of what internet provider is used, and without the need to dive into complex internet protocols configurations. In conclusion, this unbox and play device that we call Rain Beacon uses only the radio signal strength between LoRaWAN node and a gateway to estimate the rain intensity. Also, this product will be cheap enough to be massively produced and deployed by ordinary people around the world. Thus, we have all ingredients to bake a perfect cake. Now we are looking for investments and collaboration for this project. If you are interested and would you like to join us, please send us an email to the address below. Thank you very much for your attention. Have a great day.
Hello everyone, I am Vatsalya and I am 16 years old. I am a student studying in grade 10 and I live in India. And it has been more than 2 years since I have been making projects with Arduino. So now let's discuss about the project. So my project name is Krishi Navinikaran, which means development in agriculture. The technology which we use in this project is Arduino and MIT App Inventor to create hardware and application respectively. The aim of this project is the upliftment of farmers who are not aware of the cropping seasons and the adequate situations of the climate. My basic idea at first was to make aware farmers with government policies and schemes given to them so that they're not fooled by anyone according to their consumption and production. I started this project 6 months back for my school competition and added Arduino in it in less than a month ago. So now it's time to showcase my app to all of you. The app looks something like this, and if you look closer, there's an option for first temperature and humidity sensor. And when we click it, a different screen opens, and this is somewhat the layout. And then we have to connect it. You can see my Bluetooth module is visible at C05, and I'll then click it. As you can see, it is giving temperature 24 degrees Celsius and humidity 95 degrees Celsius. Now let's show you the hardware. The hardware looks something like this, and it contains one DHT11 sensor, one HC05 Bluetooth module, and an Arduino Uno, and some resistance and wires. So that was it. I told you why I started this project, the technology which I used, and the basic aim of this project. You can get in touch with me on my email ID, that is vathbhadauria@gmail.com. I'll write my email ID on this. Thank you so much.
Hello. So, taking advantage of having you both here, thanks for participating. I'm really happy to have you, like from Venezuela and India, and this is really great. So we already have some questions. So the first one for Jesus. Which basic skills would you require for a user to install her own rain beacon? How long did it take to prototype the whole project?
Okay, thank you very much. I'm very happy to be here with you, with all audience. Our idea is to have a very easy device that you just place it in outside and just turn it on. Then you need to be near a LoRaWAN gateway, and that's it. All the information, small packages of information flies to the LoRaWAN gateway, and the whole system calculates the rain, the based on the LoRa strength signal.
Okay, yeah, I think I forgot to mention that that it was using LoRaWAN technology, your project. So this is
Yes.
pretty good to know. Good. So we have another question for Batsiala. Can you can already turn on? Oh, sorry, I'm reading the wrong question. Good. Let me go. Which are the possible applications of this project? Who is the perfect end user, and how many parameters can you measure at the same time? So this is a group of 3 questions. So let's see. Thank you.
So the possible applications of this project is either to measure temperature or humidity. Other than the IoT feature, we have added all the information that a farmer needs from sowing to the harvesting of a crop, including all the government schemes, policies, and also a farmer's helpline number, which the farmer can directly contact with the government. Also, also the perfect user end of this project that I made is the upcoming farmers or the farmers who don't have any knowledge about their adequate moisture of the seasoning of the crop or the climate regarding that.
Yeah, my project it's very useful for farmers too. The production of wine it's very important to measure the 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 rain, because too much rain in the grape fields it will be not very good. It doesn't have to have too much water, and but you can use it for example, oil industry applications, because you need to measure rain when it's raining because several reasons. And here the question says, how many parameters can you measure? Well, you can measure as any parameter if you want. For example, pressure, temperature, humidity. You also can calculate dew point, and a lot of if you have several sensors connect to the LoRaWAN gateway node, you can send all information to the through the Helium network.
Okay, great. I think there's another question for you, Jesus. It says, has the LoRa connection been reliable in a city location? What kind of range are you getting?
Yes, very reliable. We have experience about 4 kilometers inside a city, going through buildings, going through concrete structures, and because you have a very big network, hotspot networks in China, Europe, United States. You will find a very easy, a node gateway very near from you inside a city. Now at the outside, long far away from the city, you need to install a gateway by yourself, but it will be a very wide range for each gateway,
Okay,
about
great.
kilometers.
Good. We have another question for Vatsalya. So, has your project been tested in a live location yet, on a farm, for instance? This is a really good question.
Yes, we have also tested a project in a farm, which is basically near to my home, that is within the radius of 5 kilometers. We tested this project for almost 5 days continuously to see whether this is accurately giving the information or not.
Great. I think we have a little bit of time for maybe one or two questions max, so we can give time for the next block. So this is a question for Jesus. What kind of accuracy are you getting from the rain detector?
Well, this project was inspired on an investigation I made about in 2014, and we with satellites, geostationary satellites, and we find about a 90% of accuracy. Now we are working with Arduino devices on LoRa network, and we are getting more or less the same accuracy, 90%.
Oh, great. Do we have any other question? I think we don't have more questions. It appears so. We are checking here our. Okay, let me see. Yeah, another question for Batalia. Are you planning to add anything else to your project? Another great question. Yeah.
Yes, I am planning to add several components in this project. One of them is a live geolocation of the temperature and humidity of a location. For example, I am sitting in a different state and a guy is sitting in a different state. So to connect, we are actually planning to geolocation satellites, which would actually help to make a real difference for this project.
Great. I don't know if we have time for another question, but I think we should move maybe to the next block so we can present the next projects. And I want to thank you both, Jesus and Vatsalya, for
Thank you.
sharing your work with us. Thanks a lot, and we wish you the very best.
Thank you very much. Have a great day for all.
Good. So we are going to move now to the next block for two more projects, two more community projects that are going to be really, really good as well. Because the first one is going to be about energy and about biogas. So there's a big agenda for clean energy. And these next project is going to be presented by Edson M. Stanley from Tanzania. So, and it's all about the biogas production and how the biodigesters can be integrate Internet of Things in their technologies and how the production of methane can improve. So let's watch this, and then straight after, we are going to show you the project from Andrew Anger. So this project is about reliable sources of clean water for communities in different places where there's a mindset for improving the infrastructural needs and to ensure that the hand-pumped water wells remain fit for that purpose and they last as much as possible. So let's go to these two projects and then we'll come back with more Q&A and stay with us.
Hello Arduino family, happy Arduino Week 2022. Can't wait to share with you the impact Arduino's play in the biogas sector here in Tanzania. So one of the big agendas in the world now is reaching to net zero emission in the few years to come. And we have explored many solutions available in the world like hydropower, solar energies, and electricity in general. But also we do have a sector that's minor, but it's going to be playing a major impact in third world countries. That's using the biogas. And biogas is one of the solutions that is quite easy and cheap to use, but also it's a solution that's going to be cost effective into these low middle income countries. Yes, so biogas as a clean energy solution has some outputs from its production. And 2/3 of it is methane, and around 1/3 of it is carbon dioxide with some minor, other gases. And but methane itself is something that has the same compounds as the natural gas, so as well can be used into the mobility services, into the production of electricity, but also into production of the cooking energy solutions. And together with that solution, that means we can leverage the use of methane, and we can bring big solutions into our communities and create impact alongside the way. So with many Arduino features available now in Arduino 2.0 IDE, the boards that have been created, including the Arduino Nano BLE, we are now able to deploy our values into the cloud, as well as help us to get real-time data from the biodigesters. And together we can determine the temperature values. We can be able now to understand the performance of the biodigesters into different temperature situations, into different regions. And with all these solutions through Arduino, we can be able now to develop something that's bigger, something that's going to be impactful in the community. So one saying that is that we also deploy machine learning now into the community and into the devices themselves. Because with machine learning, we can be able now to get patterns of what we have been creating and try to understand the performance of the biogas into our communities, into our biodigesters, into our machines. And with all this data, with all this, supervised learning issue, now we can be able to build up even better performing biodigesters, but also come up with bigger solutions in the community. Since 2016, we've been working on different project iterations of our idea, which was basically building a standalone machine that could provide biogas and methane gas in general for cooking in rural areas. We have worked with this for a long time, and we have, in all our iterations, we have been using Arduino as our major solution. It has played a major part in giving us good readings. And for now, you're now iterating into something else. We are building big village centers, which will help to get good raw materials for biodigesters and so forth. Talking about the biogas again, with the Arduino sector, Arduino has continued again to be a major key player in helping us, especially for students, for tinkerers, for us technologists who are trying to play around with these machines, learning around and getting different solutions. It has been a greater help since it has got, the educational space, the community around the Arduino, which helps to learn and to grow alongside the community. And through this, we get many solutions, many breakthroughs, even without hustling and even without going deeper into other solutions. So in my daily practicing of Arduino programming, I always stick on the major concepts that were written in Massimo Banzi's book, which is basically to understand that in this whole process, you need to have sensors, you need to have the processing unit, then you need to have actuators in the process. So once you understand that basic ground, then it's so easy to innovate around that space and come up with a lot of projects. So we have been using sensors, actually MQs, humidity sensors, temperature sensors, and also I've been using actuators like motors to try to drive in the biodigesters. And I've used the microcontroller itself, the Arduino Uno. And now we are trying to look around working with the Arduino Nano BLE, since it has got the IoT features for us to help us actually to move forward in our project. Machine learning also is something that we are looking into to work with, since it will help actually to understand the patterns of the readings that we are getting from the sensors themselves. And through the application of the Arduino, advancing the boards and making them, equipped with the processing power to make sure that we can put those readings, we can, put the supervised learning processes within the boards and still get the predictions and everything we need. This kind of gives us hope and courage to continue working in the engineering space, but also to continue tinkering around with these projects to come up with very well-refined, impactful solutions to the community. So I see the future of artificial intelligence in Arduino. I see the future of all our automation processes in the artificial intelligence, and through Arduino I think we're going to reach a good point. So having said that, I'm very excited and happy Arduino Week 2022.
Hello. First, I would like to thank the Arduino Week 2022 Organising Committee and specifically Silvia Golfo for help and support and the opportunity of presenting this project here today. My name's Andrew Ainger and I have been involved in IT since the 1960s. Now that's before even known as IT. I started work at Plessey in Caswell on their R&D side, developing one of the first solid-state cameras, 100 pixels, that's 10 by 10 matrix. Anyway, but it was very sensitive. Now I moved to Oracle Electronics in London for a couple of years, and then I went to South Africa for 4 years. It was a great time over there. Later, I moved to Marconi and supported some 6,000 PCs and associated infrastructure together with 6,000 individual applications. Now the project we're talking about today is a well monitoring system for ongoing maintenance, or AWESOME for short. Now we've split the talk into 5 main sections. Firstly, the technology that we used and some that we didn't, the aim of the project, where the ideas come from, and the time it has taken so far, and the project status and lessons learned. The project is intended for use and is being used in Tanzania, where Swahili is the main language. Anyway, the technology we intended to use, and didn't, but we started using PLCs, relays, logic, hat calculator, and acoustic detection circuitry. And lo and behold, in 6 weeks, we got a working prototype, breadboard, you could say. However, we didn't stop there. For the first 2 years of the Awesome project, we experimented. We tried listening to the water to derive its flow. We also tried accelerometers, ultrasonics, capacitive methods, thermal methods, and impellers. We didn't really want to put impellers or anything in the water flow, as this, it was felt, that could attract mold and other toxins, which would be detrimental to its use. More recently, I have been fortunate enough to form a small group of some 25 senior engineers. That's in hardware, software, mechanical, network, even nuclear engineers have all helped and contributed to this well monitoring systems project. We have at least two things in common. Firstly, we are all retired, and secondly, we find it, most importantly, we feel passionate enough to spend time, money and effort developing a well monitoring system in this charitable endeavour. The aim of the project, of the Awesome project, was to improve water availability for rural hand-pumped water wells through targeted maintenance. Now, to achieve this, we had to develop a well monitoring system for ongoing maintenance. Now, the charity that requested this is the Eleanor Foundation, and they're based in Guernsey. It was agreed that we needed a day-to-day chart with time on the x-axis and litres on the vertical axis, so we could simply view the well status and provide targeted maintenance when and where necessary. We also needed to check that the Awesome unit itself was functional, and so we viewed the temperature, battery voltage and the daily power cycle time of the Awesome unit. We then had to make a big decision. If we were to make progress, we had to learn a new language. Now, at our age, it was going to be very difficult, but we bit the bullet, so to speak, and we learnt C++. It's fantastic. The best decision we ever made, and within the first hour of the first Arduino, landing on my doorstep, I actually got an LED to flash. I know, simple, but it was exhilarating. We also wanted to make sure that the Awesome unit could be retrofittable to any well. Eventually, we focused on one of our Arduino Pro Minis based prototypes using a low band Doppler radar module as the main sensor. It's amazing, really, that the radar unit module cost less than a pint of beer. Anyway, during the next 2 years, we refined and tested the Arduino prototype. We tested in the winter, we tested in the summer, we cooked it, we froze it, to try and identify its operational envelope. Testing was key. We didn't want to deliver something to Tanzania that was DOA, dead on arrival. It was tempting to improve continually some of the already functioning modules. However, this activity was resisted, as the target was to get something in country as soon as possible. We wanted to make sure the complete end-to-end process was understood rather than individually. Now, the next 2 years was spent testing in country, in Tanzania. Now, Tanzania is a difficult place to work in, both socially, technically and environmentally. However, the full end-to-end system is now well understood and further developments are already underway. Right, we looked at the technology used and some that wasn't, though shouldn't be considered, but never mind. We looked at the aim of the project about continued maintenance through well maintenance, well monitoring, and then where the ideas come from through testing and the charity. And we've had an inkling of how long it's taken so far. That's the time. Now we come on to the project status and the lessons learned in particular. Right, during the project, the lessons were learned, well, identified really, as it's up to the individual to learn, but they call them lessons identified. There are many, but the top 5, we feel, are: the first real lesson was power. The initial experiments used a microphone to listen to water flow and performed Fourier analysis to determine the volume of water. However, the power that this took was significantly more than could be provided by the small spout-mounted solar cells, 10 times more. The second lesson could be summarized as, if it ain't broke, don't fix it. There was a great tendency to develop further and improve further already functional subsystems at the expense of time delay. The next lesson was test, test, test. By pushing the system to the extremes of temperature and environmental conditions, we found that we felt we understood the environmental and operational envelope of the awesome unit. How wrong we were, but anyway. Fourth, the next lesson was obsolescence. Obsolescence in hardware, libraries, even suppliers. We had to second source things really quickly. And the fifth lesson is, don't assume anything. Yeah, don't assume anything. It was assumed, for example, that all the SIM cards performed in a similar way. They don't. It was assumed that the buck boost voltage regulators performed as advertised. They don't. And it was also assumed, a little bit closer to home this, that all Arduino Pro Minis performed in the same way. They don't. For example, some Pro Minis that we sourced from alternative sources, shall we say, had the wrong bootloader installed. It took us weeks to find that out. Finally, generosity. It is amazing to see just how generous the volunteer team are, not only financially, but also in the time spent developing and discussing the systems in general. My sincere thanks go to all people all over the world that have helped in this charitable endeavour. As I said, it's really fantastic. Conclusions. Well, we now have a well system for ongoing maintenance, which is available to deliver SMS, FTP or email. 5 key data points. The key data points are the pump count, that's the volume of water, the battery voltage, the maximum internal temperature, the number of texts sent to date since the reset button was pressed, at the time the unit has been powered up since the last text, that day. This data ends up on the website, enabling people to, with the URL, to provide in-country targeted maintenance as and where necessary. As for the future, well, we are already improving several aspects and are starting even to adopt Excel-based machine learning too. When you think about it, the 5 data points provide us with a pattern every day, and these lines add up over time, and this can be used to determine whether the well is poorly or not. This brings us to neural network machine learning aspects. We did produce an animal of a spreadsheet. It consisted of 10 neurons, that's over 100 test neurons, but it was painfully slow. Well, it was 75 megabytes, and every epoch took 30 seconds, and it was 100 epochs per run. But anyway, never mind. It's not that size anymore, and it seems to work quite well so far. But that's another discussion. Now, finally, most of our data is on GitHub. Also, the circuit diagram, the parts list, the technical and training videos are all on www.wellmonitoringservice.co.uk. Well, thanks very much for the opportunity of talking about this. We still feel very passionate about it and excited about its progress and the future. Anybody who wants to help, please give me a call. Thanks very much. Any questions?
Great. So now it's time for the Q&A. Welcome, Andrew, Edson.
Hi there.
How are you?
Hello.
Hi there.
Great presentations, both.
Can I ask you a question, please? Can you hear me okay?
Yes.
Okay. Whereabouts in Tanzania are you?
What? Sorry, again, I couldn't hear.
Whereabouts in Tanzania are you?
Oh, for Edson.
Oh, for Edson. Oh, okay, yeah. So I'm in Dar es Salaam.
Ah, okay.
Dar es Salaam City.
Excellent. I'd like to have a chat with you sometime offline.
This is really great that you are connecting through different, location coincidences for your projects. Thank you.
Yeah.
I think there were like very nice presentations also on the process that you took. So we already have questions for both of you. So I'll start with the first question for Edson. It says, what sensors do you use in your monitoring of biogas production, and how are they positioned within the system?
Okay, yeah, well, thanks for the question. And yes, so basically the biogas itself and the biogas sector in general, in Tanzania, we of course we did our first prototype when we were in college, and after doing that, we didn't get the results that we wanted. And once we were in the community, we went and tried to do the biogas project. And what came out was that we did not know exactly what we were obtaining from the project, So we tried to think, as maybe for those who attended the session in the evening, Massimo and the ARM professional were talking about that they are trying to unlock the technology. People have got problems and solutions, but once they come to think about technologies, that becomes like a barrier. So with Arduino and the partnerships that you create, you're trying to unlock the barrier. So what we did in our project, we went to back in our programs, and we found let's use MQs. So we use MQ4 sensor for determining the methane and the CNGs. But again, we use the MQ136 to try to understand about hydrogen sulfide. So because hydrogen sulfide is one of the deadliest ones in the biogas in terms of damaging the pots and the other tools with steel. So we have that, and the way we position them in the biodigesters, in our first prototypes, we had, we created we call it the on the ground biodigester, which was created on top of the ground. And the way we positioned it was the wrong way, because we were not getting exactly the good readings, and we were not. But once we went to do it in the ground biodigesters, which have got a dome structure. So what you do, the sensors stay on top of the dome structure, which could be very easy for people to, get the readings and also get the direct contact with the gas that's coming out to go to the stove and to the other storage facilities.
Thank you. This was a great answer for all of the prototyping rounds that you have to do to improve your project. Good. So we have a question for Andrew. So it says, what was the problem with using PLCs for this?
Can I share my screen?
I think so.
Can I try that? Because I'd like to show you. Share screen. Here we go. See what happens. That's all right. Is that okay, guys?
Yeah.
Okay, good. All right. You said what was the problem with the PLCs?
Yes.
All right. Let me show you. That was the raw materials that we used. They were the wells that we were looking at. Oh, don't tell me. Oh. Basically, I can't find it. That's a shame. I do apologize. Basically, okay. it was power. We ran out of power. It all worked. It was fine. We took the Fourier analysis. We got the derived water flow, and you could ring up any well, and it would tell you how much water had been used. But it took 10 watts. And of course, those little tiny solar cells, we couldn't provide 10 watts. Even in Tanzania, even though it's very nice sunlight, in Tanzania for 12 hours a day, I think. We couldn't get the power, so we couldn't progress that. We had to go to something else, and that's when we had to even the DAR age. I think the average age of the team was 72. The nuclear engineer was 94. So yeah, learning C++ or a version of C++ wasn't particularly easy, but it was great fun.
I really like that phrase of like learning C++. It's never late to do that. Good. We have 2 more questions, and I think we can wrap up the session. So we have another question for Edson. You mentioned measuring the temperature. Do fluctuations in external temperature affect performance of the solution? And was there an optimum temperature?
Okay, thanks for the question again. And yeah, so because when we talk about the biodigester, it means like in just a normal language, in explanations, you can say you're just making those microbes think that they're still maybe in the cow's stomach, you know. So whatever you have to do, you have to make sure that you make them comfortable and they feel like they're still in that kind of environment. So temperature is very, very important, and that's one of the biggest challenges that affects biodigesters. So having a slightest mistake on designing the biodigester can definitely make the whole project fail. So we definitely had some fluctuations, and in Tanzania, you know, we have different weather conditions in different regions. And just to give an example, roughly, we just created an on-top ground biodigester in Arusha. And once we did that, we didn't get the good results because it was outdoor and it was on top. So it went with the room temperature, which was, you know, changing with that condition. But having the biodigester dug under the ground, it conserves the environment. And actually, the good news is right now we are trying to use, we are on the preparations of using plastic bricks, which are actually got from the recycled plastics. And we are going to use those in our biodigesters anytime soon to try to conserve the heat and make sure that the biodigesters are having that. So in the question, the temperature actually affects, the external temperature affects the biodigesters themselves. And we are still working around to try to learn how we can control the temperature. But with the help of Arduino and the IoT in general, we'll be able now to understand the performance of each biodigester. And through that, we can be able now to understand how to control the temperatures, but also what is the reaction of the production of the gases in each of the biodigesters with regard or reference to the temperature of that condition. So we are still working on that. And once we're done with that, I think we have a precise answer for the optimum temperature that we want to work with.
Great, thanks for the explanation. So we have, I think, 2 more questions for Andrew. I hope there's time. So is your monitoring system just measuring amount of water or also quality?
Not quality.
Okay.
We want it, the whole purpose was to make sure that in rural Tanzania, well, Africa, where they need it, the water was continuous flow. It was maintained. And so it was trying to keep it as simple as possible, and we just wanted to make sure was water flowing, and that's what we do. We measure the volume of water, and as I said, we measure the internal temperature and battery and a few other things just to make sure that the electronics is working.
Okay.
So no, that was all. Sorry, you said there was 2 questions.
Yeah, and I don't know, I think there's another question about solving the power issues with like either, you know, reducing the consumption or like having bigger solar panels.
No, we couldn't. We tried. We started with more solar panels, and we actually had to take one of them off because we put the solar panels too close to one another, and in the temperature up there, it got so hot that the thermal expansion, the 2 outside ones, pushed the middle solar cell off. Anyway, so we had to actually reduce the amount of solar panels. So we had to go something different. We couldn't use PLCs. We couldn't use a talking calculator. Although I thought it was quite neat using a talking calculator to tell us the volume. And that's when we had this fantastic epiphany of the Arduino. They are fantastic devices. Just wonderful stuff. Yeah, it's fantastic.
Thanks for sharing, and thanks a lot for your participation, your wonderful projects. And oh, okay, I think we lost Edson for the internet connection, but thanks a lot. I think we can maybe wrap up. I don't know if we can get Edson back, at least to say goodbye, hopefully. Let's see. Not possible. Well, thanks, Andrew. I think we can wrap up, and I want to thank you for your presentation and your participation in this awesome Arduino Week.
Thanks for the opportunity. Very much appreciated.
Thank you. Good. So we came to an end. I was having fun already. So I remember that tomorrow we have the third day, which is the community day, which I am so envious that I will not be able to host, because the projects are going to be amazing. So they're going to be about art, robotics, sound art, the thing that I like the most. Interaction, machine learning. So you're going to see amazing projects. So stay tuned. It's going to be hosted by my colleagues, Ubi De Feo and Ana Vigano. So, and also remember that tomorrow there will be a very, very important event that it's going to start, which is VET, that happens in the UK. And this is the biggest event for the global community for education technology. And of course, Arduino and the Education Business Unit with our amazing colleagues working for those products are going to be there, because there will be a very, very special announcement for something that we have been working for weeks. So please stay tuned because we are going to announce it tomorrow. And I hope you enjoyed this last session, and thanks everyone for staying with us, and thanks for all your contributions, and take care. And I'm Laura Balboa from Malmö, Sweden.